Let's talk about the service registry and discovery pattern, which I should qualify as plural, because we have a few options here. But first, this pattern aims to solve the problem of dynamically locating and communicating with services in a distributed system. Its primary purposes are to maintain an up-to-date catalog of available service instances, enable automatic service registration and deregistration, facilitate dynamic scaling and load balancing, and last but not least, improve system resilience and fault tolerance. At a 50,000 feet view, this pattern involves two main components. First, a service registry, which can be described as a database that stores information about available service instances, including their network locations. A service can either self-register at startup or rely on a third party that leverages the service's heartbeats. The second component is a service discovery, which is the mechanism by which a service can find the other services it can interact with. There are two discovery approaches here, a client-side and a server-side. We'll talk about both shortly. Let's, however, talk briefly about the main challenges of this pattern. First, we must ensure the registry is always up to date, limiting temporary inconsistencies, so that we can avoid directing traffic to unavailable instances. Then, we need to consider possible performance overhead. Frequent registry queries can impact performance. Implement caching mechanisms to reduce this overhead. Of course, the registry itself can become a bottleneck and become a single point of failure. So, please implement high availability and fault tolerance for your registry. Then, as usual, we have the problem of security. Failing to secure the service registry can expose sensitive information about your infrastructure. If you think about it, the registry is like a DNS, and while DNS-based discovery is simple, it may not be suitable for highly dynamic environments due to caching and propagation delays. A common mistake with this pattern is neglecting to implement robust health checks within each microservice, as it can lead to routing traffic to unhealthy instances. Last, failing to implement proper load balancing strategies can result in uneven distribution of traffic. So you want to avoid that too. Now, let's see how to implement this pattern. And, as you now understand, there are two components with this pattern, the service registry and the service discovery. Since I'm very logical, I'm an AI-generated voice after all, let's first look at the former. And as always, let's start with our favorite 4 sample microservices, and add to this initial picture our service registry. As all other services, the service registry relies on a database, which stores information on the microservices available within the ecosystem of a solution. So, how does a service registry work? There are two alternatives. The first one depends on self-service registration. In this alternative, at startup, each microservice registers itself to the registry. And, when shutting down, each microservice deregisters. Simple, right? The second alternative relies on a third party with a registrar that takes the ownership and responsibility to monitor the health of microservices, and registers or deregisters them based on their health status. And yes, this implies that with this alternative, if you want a new microservice to contribute to the overall solution, it must provide the registrar with the ability to monitor its current state. Now, let's look at the second component of this pattern, the discovery. How does a microservice discovers its partner in crime? Well, they discover them thanks to the service registry database. And, here again, there are two alternatives for the discovery pattern. In the first alternative, each microservice can query the service registry to retrieve the needed info of other microservices. This approach is called a client-side discovery. The second alternative is a server-side discovery, which relies on a proxy to assist each microservice to interact with others without having to worry about anything. The proxy fully takes ownership to figure out how to route requests between microservices. Pretty cool, right? Okay. That's all for today. Hit the like button. Subscribe, and I'll see you soon.